Welcome everyone to the 7th grade Unit 1 quiz review video. In this video, I'm going to go through every single question on the study guide. If you know and understand how to do every question on the study guide, then I'm sure you're going to get every question right on the quiz, okay, because they're very similar. Thanks for watching. So question number 1, fix it. Yona wanted to create a scaled copy of ABCD. They drew EFGH. Convince Yona that EFGH is not a scaled copy of ABCD, and then what advice would you give them so they can produce a scaled copy? Alright, so let's get started here. They want us to figure out why is this not a scaled copy of this. So our basic understanding of a scaled copy is that they're the same shape, but different sizes. Okay, so looking at this might appear to be the same shape and different sizes, but then we have to get to our more technical definition. So when we have a scaled copy, we have equivalent ratios for all the side lengths, the corresponding or the matching up parts of the sides. So like, for example, this here is my base of 6. That matches up here with a base of 4. So when I find the ratio from 4 to 6, it should be the same as the ratio from 1 to 2, and the ratio from 3 to 4, and of 3 to 4 there. Okay, so we need those equivalent ratios. And we'll have those equivalent ratios if there's a constant scale factor, right? So if there's some number that I can multiply 2 by to get 1, and then that's the same number that I multiply 6 by to get 4, and the same number I multiply 4 by to get 3. We don't have that here. 2 times 1/2 is equal to 1, but 6 times 1/2 is equal to 3, not to 4. So this is not a scaled copy because we don't have that scale factor or those equivalent ratios. Okay, I know in my head, though, that 2 times 1/2 equals 1. I want to show you, right, if you don't know that, how you could figure that out using a calculator and equivalent ratios. So we can do these ratios. The scale factor is always going to be the ratio, or like the fraction of, the scaled copy length, like a scaled copy side length, to the original side length. And then you need that scale factor to be the same for all the different side lengths. So here, the scaled copy that we tried to get was the smaller one, EFGH. So I'm going to have 1 over 2, and then I'm going to have 3/4, and then 4/6. And I'm getting these, right, the 4 and the 6 are coming from the bottom base, the 1 and the 2 are coming from the top base, and the 3 and the 4 are coming from the sides. Okay, so if these 3 were equal, then we would have a scaled copy. But then we can put this in our calculators, and if you do 1 divided by 2, you're going to get 0.5. If you do 3 divided by 4, you're going to get 0.75. And if you do 4 divided by 6, you're going to get 0.6 repeating, 0.6666666. So these are not equal. Okay, these are not equal. So the ratio of the side lengths are not equivalent, and there's not a scale factor. Again, these are giving you the scale factors. So like 2 times 1/2 is 1. 6 times 0.6 repeating is 4, and 4 times 3/4, or 0.75, is 3. Okay? So, not a scale factor. Equivalent ratios aren't the same. So now I'm going to just write that down because it does say we're supposed to convince Yona that they're not a scale copy, so we got to write a sentence to do that. Okay, and you could write something like that. EFGH is not a scaled copy because the ratios of the corresponding side lengths, again, corresponding means like matching up, like the same parts, are not equivalent, right? So these don't equal each other. Cool. Okay, and then 1.2 says, what advice would you give them so that they can produce a scaled copy? So to produce a scaled copy, you multiply the original side length by the same scale factor. So here we can see that we're multiplying by different numbers, right? Different scale factors. So we have to multiply by the same. So, all right, there we have it. Multiply each side length in ABCB by the same scaled factor, for example, 1/2, to get the scaled copy side lengths. Awesome. Okay, so keep going on. Here we have some key vocabulary. So I just listed the 4 main vocabulary words of this section of the unit that you want to make sure you know. So scaled copies have the same angles. So that's important when they have the same shape. It's like because they have the same angle. Okay, because they have the same angle. And then proportional side lengths, and that's what we were just talking about. If the ratio of their side lengths are equivalent, then they're proportional. Okay, and then that's one of those vocabulary words. Here we have the definition of equivalent ratios. And then here's the definition of proportional relationship, which is just a set of equivalent ratios. Okay, and you can see whenever we have a proportional relationship, there's some constant number that we can multiply one set of values for by to get the new set of values. And that's basically the same thing as having a scale factor. Okay, so to create a scaled copy, we multiply all the lengths in the original figure by the same number, and this is called the scale factor. So you can see some examples there. Then we get into the small group partner and independent practice problems, and these are really going to mirror some of the questions on the quiz. So first, we have the original and 3 copies, and we're told to choose which of the copies of the original triangle are scaled copies. So they're not necessarily all scaled copies. Okay, so to figure that out, we're going to try to see, is there a scale factor, right, that we can multiply each of the corresponding sides to, each of the side lengths to get to the copies. Okay, or we could take the ratio of the side lengths. So it kind of depends, like, how well you can see multiplication, like how well you know your multiplication facts to get the first one. Like me looking at this first copy, I would say, okay, this is 5 and this is 10, this is 4 and this is 8, and this is 6.4 and this is 12.8. So I just look at that and I say, oh, that's a scaled copy, and the scale factor is 2, because I know that 5 times 2 is 10, 4 times 2 is 8, and 6.4 times 2 is 12.8. Okay, so that is going to be one of the scaled copies. But if we don't know that, in our heads, or even if you do, you could write that out. You could show it by saying, okay, here's copy 1. Let me try to find the scale factor by doing that ratio that I was doing before. So I can do the scale factor, SF, is equal to the scaled copy length divided by the original lengths. Okay, for all the pairs of like matching up ones. And then I can see, okay, in this case, we're going to have the scaled copy. In this case, copy 1 is going to be 10. The height is 10, so 10 compared to this height of 5 in the original. The base 8 to 4, and then 12.8 to 6.4. And we can see, are those equal? So then we could use a calculator, or do lots of different ways, and these are all equal to 2, and then 2 is my scaled factor. Okay, so for copy 1, yes, this is a scaled copy. Okay, and then we want to do the same thing for copy 2 and copy 3 and see if we get this. Okay, so now for copy 2, we're going to do the same thing. We're going to try to find the scale factor by finding these ratios, and if all the ratios are the same, then that tells us what the scale factor is and that we do have a scaled copy. Okay, and then let's see, are these equal? And if we divide these on a calculator or some other way, we're going to get yes, that these are equal. They all have a value of 0.5. So again, since those are equivalent ratios, the ratio is telling me what my scale factor is, and both copy 1 and copy 2 are scaled copies. Okay, so for copy 3, I did up the workout here. So I'm trying to find those same ratios. I'm taking the ratio of the height of the copy to the height of the original, the base of the copy to the base of the original, and then this long side to the long side. And when we do that, 6/5 isn't equal to 3/4, which isn't equal to 6.7 divided by 6.4. So we put those on the calculator. We're not going to get the same number. They're not equivalent ratios, so copy 3 isn't a scaled copy. And we might be able to know that just by looking at it. It does look like it's skinnier by how it's drawn, skinnier than the other two, in a way that's like it's taller and skinnier versus the original. So it doesn't quite look like the same shape, even though it is a right triangle. Cool. All right, so moving on, we've now done 1.1 and 1.2, because 1.2 says for each scaled copy, determine the scale factor from the original to the copy. And then in 1.3, we're going to sketch another scaled copy of the original triangle using a different scale factor. So right now we've used a scale factor of 2.5. So I'm going to try to make a scale factor of 3. I just think that's the easiest here, but you could use another one. But 3 is probably the easiest. So my original had a height of 5 and a base of 4. So I'm going to say, okay, let's pick a scale factor of 3. Originally, I had a height of 5. So I'm going to have a height of 5, and then I'm going to multiply by 3, and that's going to give me my new height, which is going to be 15. Originally I had a base of 4. I'm going to multiply by 3, which is my scale factor, and get a new base of 12. And then originally I had this long side of 6.4. I'm going to multiply by 3, and then it's going to give me 19.2, which will be my new long side. Okay, so now I'm just going to draw this. This is 15 units. I've counted it, so, you should count it too. But that's 15 units tall. Then we'll go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 units, that's going to be my base. And then if I connect this, that's going to create the right triangle, and this side has to be 19.2 units. So that's now a new scaled copy of my original with a scale factor of 3. And then finally on this question, it's saying, suppose you wanted to scale the copy that you drew back to the original size. What scale factor should you use? So we got from the original to the scaled copy by multiplying all the side lengths by 3. So now we're saying, okay, we're at the scaled copy and I want to go back in the other direction. What can I multiply by? So like the opposite of multiplying by 3 is dividing by 3, but that's equivalent to multiplying by 1/3. Okay, so that's this important kind of fraction relationship. These are reciprocals. Multiplying by the opposite of multiplying by a whole number, like 3 or 4, is multiplying by like 1/3 or 1/4, that number flipped into the denominator, okay, which is called the reciprocal. So the scale factor should be 1/3. That's going to take it back to the original side. Okay, we'll see that more as we keep going. Here we have figure B is a scaled copy of figure A. In 2.1, label each missing side length so that the side lengths of figure B are proportional to the side lengths of figure A. So again, this word proportional, that means there's equivalent ratios. So basically this is a scaled copy, and there's some constant scale factor that we're multiplying by to take us from A to B, and we can figure out what that is by dividing the scaled copy side lengths by the original. Okay, so looking at this, I'm going to find what my scale factor is by looking at these corresponding sides. So this length is originally 5, and my new one is 15. Again, I know my multiplication facts. I know that 5 times 3 is 15. So I know that that's going to be the scale factor from A to B. If you didn't know that, you could do 15 divided by 5 on a calculator, and that would give you 3. Okay, the same is going to be true here. 2.5 times 3 is 7.5, but if you don't know that, you could divide and get it on the calculator. So that means that my scale factor is 3. I'm going to skip ahead and write that for this question. What's the scale factor from A to B? It's 3. It's getting 3 times larger for each of the side lengths. So then to find the new missing side lengths, I just have to use that. So the original base is 6. I want to get my new scaled copy base, I take that 6 and I multiply by 3, and 6 times 3 is 18. So that's going to be my scaled base. And then the same thing here, I have 1.5, I do 1.5 times 3, and that's going to be 4.5. So those are going to be my scaled new side lengths. The ratio of all those side lengths now will be 3, which is my scale factor. And then as before, 2.3 is saying, what's the scale factor from B to A? So to get from A to B, I'm multiplying the side lengths by 3. What can I multiply the side lengths by in B to get back to A? And just like before, the answer is going to be 1/3, okay? Because multiplying by 3 and multiplying by 1/3, those undo each other. They take you back to 1, back to the original. Cool. All right. Question 3. Triangle Z is a scaled copy of triangle M. Select all the sets of side lengths that are possible side lengths for triangle Z. Show your work. Okay, so here we're just trying to figure out, right, like this is my original, this is the original, and which of these could be scaled copies. So just like we've been doing before, we're going to find those ratios. So for A, I'm going to try to find the scale factor. I'm going to take the same as I've written many times already. To find the scale factor, you're finding the scaled copy length, okay, dividing by the original length, and then we want to make sure that's going to be the same for all the side lengths, and if it is, it's a scaled copy, and whatever number you're getting is your scale factor. So for A, these are going to match up from getting bigger to smaller, so the smallest numbers should always match up. The middle numbers should always match up, and the biggest should always match up. So in A, my scaled copy length is 8 compared to 4, and then we're going to have 11 to 7 and 10 to 14. Okay, and that's where I'm getting those from. And these are not equal. Okay, so you can put that in a calculator. This is equal 8/4, this is equal to 2. This is going to be a messy decimal in between 1 and 2. And then this is going to be in between 0 and 1. So since those are not equal, we don't have equivalent ratios, this is going to be not a scaled copy. So it's not A. And then we're going to do the same thing for B, C, and D. So I'm going to do that fast, jump ahead, and then we'll see what happens. While I was editing this, I realized I made a mistake. In both A and C, those last fractions should be flipped. So it should be 14/10 and 15/14. But that's not going to actually affect the answer. Neither of them are scaled copies. So everything else is still true. Okay. All right. So you can see that the answer here is going to be B and D. So for B and D, when we take these ratios of 2 to 4, 3.5 to 7, and 5 to 10, where all those ratios are equal, we get a scale factor of 0.5. So that's a scale factor. And then for D, we're going to do the same thing. 10/4, 17.5 sevenths, and 25/10, all equal 2.5. So since those ratios are equivalent, it is a scaled copy, and 0.5 and 2.5 are our scale factors. In A and C, we get not equivalent ratios, so those can't be scaled copies. Okay. Question 4 says figure D is a scaled copy of figure A. Select all statements that must be true. Figure D has the same number of sides as figure C. So let's see, when we have a scaled copy, do the two shapes have to have the same number of sides? Yes, they have to have the same number of sides, right? They have to be the same shape, so they have to have the same number of sides. So that's right. Figure D is larger than figure C. So must that be true? Must figure D be larger? No, it could also be the same size if the scale factor is 1, or it could be smaller if the scale factor is between 0 and 1. So that doesn't have to be the case. C, figure D has the same angle measures as figure C. So that is true. When scaled copies are the same shape, it means they have the same angle measures as well. So that has to be correct. And then D, the scale factor from D
figure D to figure C is less than 1. That does not have to be the case. It can be the case. That will make our scaled copy smaller, but it doesn't have to be the case. For question 5, we have another select all of the true statements. Triangle DEF is a scaled copy of ABC. So we know that these are scaled copies, and we're trying to see what's true about them. Okay. Angle A has the same measure as angle D. So here's angle A, and then here's angle D. If we know that these are scaled copies, we know that the angle measures that match up or correspond have to be the same. And when we look at it, we should see this. Even though the shape is bigger, this is like open the same amount. So yes, this is going to be true. Those angles are going to match up. Angle B, which is here, has the same angle measure as F, which is there. Okay, so that's not going to be the case. What it should be, angle B here is going to have the same angle measure of E, because those are in the same spot, right? Those match up. They're corresponding. But B and F are like different parts of the two different triangles, so that's not going to be the case. C, one scale factor in this situation is 3/2. Okay, so we're trying to find scale factors here. So to find the scale factor, as we've been doing in the whole video, we can find the ratio of the side lengths. So like from 6 to 9, what are we multiplying by? From 4 to 6, what are we multiplying by? And from 5 to 7.5. So we can do 9/6, 6/4, and 7.5 fifths. Okay, and if we put those in the calculator, all those ratios are going to be equal, and they're going to be equivalent to 1.5. So then back here, it's saying one of the scale factors is 3/2. Well, what is 3/2 as a decimal? That is equal to 1.5. So we could do that on a calculator. 3 divided by 2 is 1.5. So yes, this is going to be right. That's going to be one of the scale factors. The reason we're saying one of, because that's the scale factor when we go from the smaller one to the bigger one. Okay, times 3/2 or 1.5. But then we can also go in the other direction. We can go from the bigger one to the smaller one. We could do the same thing. We could set up the ratios, but now in the other direction. So we could do 6/9, 4/6, and 5 divided by 7.5. If we did that, we'd get 0.6 repeating, which is equal to 2/3. Okay, so that's also going to be correct. Or without doing that, you could see that 3/2, 3 divided by 2, and 2/3, 2 divided by 3, these are equivalent ratios. Or sorry, they're reciprocals. Yeah, they're not the same, but they're reciprocals, so they're the flip or the opposite of each other, and they're going to multiply to 1. So that is going to be the case. And then finally, the ratio of AB to AC is equivalent to the ratio of DE to DF. So right off the bat, if we know that these are scaled copies, we know that the corresponding ratios are the same. So I'm inclined to think this is yes, but we can check with the numbers. AB is 4, and AC is 6. And then DE is here, and DF is here. And we can figure out, are these equivalent? Writing it as a fraction and then dividing is normally the easiest. Put those in the calculator or simplify some other way. And yes, these are equivalent ratios. Both of those simplify to 2/3 or 0.6 repeating. So yes, that's going to be the same. For these select all of the true statements questions, you really have to go through every single answer and try to make sense of it. Question 6. Figure B is a scaled copy of figure A. Calculate each scale factor. So look in here from A to B. I'm just going to label some information I have. This is 3, and this is 1. This is 6, and this is 2. So from A to B, it's getting smaller, right? My ratio is getting smaller. And to find the scale factor, I could take the side lengths and divide them, right? So I could do 2/6 or 1/3. And that's going to give me my scale factor. It's getting a third as small. Okay, or 0.3 repeating. Again, this is smaller, so my scale factor is going to be less than 1. So that's in this direction. It's times 1/3. But then if I want to go in the other direction, from 1 to 3 or from 2 to 6, I'm getting 3 times bigger. So my scale factor is going to be 3. Okay, and to do that, I could do like 6 divided by 2 or 3 divided by 1, which equals 3. Same idea for B. This is 1, this is 2, this is 4, this is 8. So in this case, from A to B, it's getting larger, so my scale factor should be bigger than 1, and I'm multiplying by 2. 4 times 2 is 8, 1 times 2 is 2. And then from the other direction, I'm getting half as small. These are the like inverse scale factors, right? I could do 1 divided by 2 or 4 divided by 8. Those both equal 0.5 or a half. So we see this relationship between the scale factors in both directions. They're reciprocals, you multiply them and you get 1. Okay, last page. Rectangle S is 4 units by 5 units. 7.1, draw a scaled copy of rectangle S with an area of 80 square units. Label each side length of the copy. So to do this, we just have to think about how do I get a rectangle that has an area of 80 square units. To find the area of a rectangle, we multiply the side lengths. So what are two numbers that multiply to give me 80? 8 and 10 are two numbers that multiply to give me 80. Okay, and that's probably, right, it's probably the easiest way you can get it. There's going to be a question really similar to this on the test, and it's going to be a really similar setup, right? Think about what's the easiest two numbers to multiply to give you 80, and you should be able to see it from there. So we're going to now draw a rectangle. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That has a height of 10. 2, 4, 6, 8. A width of 8. And then, of course, then this rectangle is going to have an area of 80. How do we know it's a scale factor of 2? Well, we know that my original side length here was 4. If you do 4 times 2, you get 8. And the other side length was 5. 5 times 2 is 10. And then we know that 8 times 10 is 80. So since it says explain, I'll write that up briefly. So when you multiply the original side lengths by 2, you get the new side lengths of 8 and 10, and those multiplied to give you an area of 80 square units. Then we have 8.1. Are the side lengths in figure 1 proportional to the side lengths in figure 2? Explain how you know. So remember, proportional means that there is an equivalent ratio between the side lengths. So basically this is just asking, are these scaled copies of each other? Because scaled copies have proportional side lengths. So are these scaled copies? No. Looking at it, they don't really seem like the same shape. How do I know that exactly? So here, down here, this is 6 units. The base is 6 in the original. Okay, and it's 3 down here. This is 2 and this is 1, so those look promising. But then when we compare the height, this has a height of 2 units and this is a height of 2 units. So if I find those ratios, we would be 3 divided by 6. That does equal 1 divided by 2, but it doesn't equal 2 divided by 2. These equal 0.5, so like the bases got half as small, but the height stayed the same. So all the dimensions didn't change by the same factor. So explain how you know. The bases got half as small, but the height stayed the same. So all the ratios are not equivalent. Okay, and finally, now we want to draw a scaled copy of figure 1 using a scale factor of 1/2. So figure 1 we have here, it was originally 6 units, has a base of 6 units, a top base here of 2 units, and then a height of 2. Okay, so when we have a scale factor of 1/2, we're going to do 6 times 1/2. That'll give me 3. 2 times 1/2, that'll give me 1. And then again, 2 times 1/2, which will give me 1 for my height. 3 units. Okay, my height should be just 1 unit. And my base up here should just be 1 unit. So when I draw like this, I have a scaled copy of figure 1. The height is half as tall now, and the bases are half as tall. All right, so I know that was long. The quiz is a little bit shorter, but if you understand everything in this video, and you can do these problems all yourself independently, then you're going to be in great shape for the quiz. I recommend now that you've watched this, you go back and you redo any questions that you didn't understand the first time with your notes to the side and see if you can do it. Okay, good luck, everyone.